Right triangle trigonometry. So the reason why we're saying it's right triangle trig is because it's dealing with right triangles. I know that seems obvious, but there's also, when you deal with law of sines and law of cosines, you can have other triangles. You can deal with trigonometry doesn't just deal with only right triangles. That just happens to be where we start it and build our foundation from there. So, how can you find the trig function of an acute angle theta? Well, first thing, you better know what this is. Theta. Theta just happens to be another way of saying angle. Like in the past, you've just called it angle x. Like you used a variable. We now call it theta. Okay? Greek. There, we use the symbol theta. If you were to look on your graphing calculator, not that you need it much right now, but you'll notice that there is a little button right there where we use our variable key. X, T, theta. Hey, all right, theta. All right, so now you'll still see X when you plug in theta, but that's okay. All right, so this is just a variable. It represents an angle. All right, now the trig functions most of you are familiar with are sine, cosine, and tangent. Yes, and we use the phrase Sohcahtoa. If I have time on another day, I will tell you the story, the Legend of Sohcahtoa. It is the legend. All right, but right now I can't. Okay. Though my son should have heard that legend this weekend as he ran into the side of the of his bed. Ouch. All right, Sohcahtoa there. Yeah. Sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent is equal to the opposite over the adjacent. Now, for those, let me just get I'm assuming I'm not telling anyone anything brand new yet. Is that correct? Okay. So, one way to write this, writing Sohcahtoa, is to write it this way. Okay, I should have given myself a little more room, but all right. That way you can actually see the fraction. Sine is opposite over hypotenuse. Adjacent over hypotenuse is cosine, and tangent is opposite over adjacent. What we mean there is based upon our angle. So when we're looking at a triangle, the best way to figure this out, like if I trace the angle, one thing that students have a hard time with is labeling the sides. If you trace the angle you're dealing with, theta, the side you do not trace is always your opposite side. Okay? The side, the other leg that you do trace is the adjacent, and then the longest side is always your hypotenuse. The one across from 90 degrees is your hypotenuse. All right. Notice sine is S-I-N-E. We abbreviate it as S-I-N. It is not sin, it's sine. You're not doing something wrong when you're calculating sine. Okay? Cosine is the complement of sine. That's a little foreshadowing for later. Tell your neighbor what complement means. Does not mean being nice in math. Okay? It's not like nice hair. All right. Okay, and tangent. Tangent, we abbreviate T-A-N. Okay. Please note that cotangent is just the reciprocal of tangent. It's called a reciprocal function for that reason. Secant and cosecant are also reciprocal functions. Tell your neighbor which function secant is the reciprocal of. Okay, now secant is the reciprocal of which one? Cosine, which seems weird because this one starts with an S and that one starts with a C. But that's just how it is, okay? Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. They are reciprocal functions. If you flip the fraction the ratio for sine, you get cosecant. If you flip the ratio for cosine, you get secant. If you flip the ratio for tangent, you get cotangent.
Oh, this is going to be fun.
What's that?
Why is it called cosecant if it's reciprocal of sine?
It's the complement of secant. Cosecant means the co in front means complement of. Cosecant. Okay. All right. Very good.
Is there a reason that tangent complement is also reciprocal?
When we go through these, we will. Hey guys, can I get everyone focused back up here? Okay, I really want to make sure that with these two, you understand that cosine is the complement of sine. That's kind of one of our big pictures here. Okay, and then knowing the reciprocal functions. I'm not so concerned about co and cosecant or co and cotangent, other than that they're reciprocal functions. But these two, understanding that this and this are complements. That if I know this, okay, its complement is this. That means the two angles add up to 90. Okay, so we'll get to that. We'll see that as we progress here. Okay, I'll try to bring that to light when I talk about the complement of it. Okay, what I'd like you to do is take a look at exploration number 1. Find the exact values of sine, cosine, tangent functions for the 30, 45, and 60 degree angles. Okay? All right. Just so you're clear what's being asked, I will do the first one for you. Sine of 30. The sine of 30 has a ratio. If I trace my 30 degree angle, now note we're going to have to use 60 here in a minute, so you may not want to trace in pen like I did, okay? Unless you have a highlighter handy. Okay? The opposite side would be 1. The adjacent side would be root 3, and the hypotenuse is 2. Sine is equal to, if we use our cool little jingle there, or whatever we want to call it, Sohcahtoa, our little song. Yeah, we could come up with a song. I guess we'd have to have that to call it a jingle. Okay, opposite over hypotenuse. Mackenzie's going to write us a song. Thank you. Okay, sine of 30 is equal to 1/2. That's the opposite length over the hypotenuse length. That's all you're being asked to do there. By the way, you will get sick of that number by the time we're done with this chapter. 1/2. You're like, sine 30 is 1/2. Yay. Okay, moving on. Okay, it'll be a dream. You'll be like seeing 1/2 floating like sugar plums in your head. Okay? All right, there we go. Fill out the rest of them, please. You've got to get cosine and tangent. Then you have to get sine of 60. And then you have to also get sine of 45. Yeah, it's like 9 things. That's advanced math right there. At its best. Okay?
So is the test just going to be like 4 problems that take 90 minutes each?
Sounds like a plan. Good idea, Walsh. Walsh always thinking. All right.
We just talked about how it was our last chapter for a second, guys.
There is a chance it's the last chapter. There's a chance that we may try to do the other chapter.
Yay!
I don't know that. All right. This one is what? Root 3 over 2. This one is? 1 over root 3. Can't leave a root in the denominator, so we call it root 3 over 3. For those of you who don't know how to do that, you're like, whoa, what is that magic? You'd be like 1 over root 3 times root 3 over root 3. This is rationalizing your denominator there. That gives you root 3 over Root 9, which is 3. Okay? That's just an expectation that we know how to do that now. Sine of 60 is? Root 3 over 2. Cosine of 60? Tangent? Root 3, right? Over 1, which is just root 3. Okay, now I want to pause for a minute there and have you take a look at how sine of 30 and cosine 60 relate. And how cosine 30 and sine 60 relate. Right? The sine of 60 is the same as the cosine of 30. And the cosine of 60 is the same as sine of 30. That has to do with them being complements of each other. Right? Okay, sine of 45 is? Good. 1 over root 2, which is root 2 over 2. And cosine 45 is also 2 over 2. And that makes tangent 1. Now, how do you get tangent? Well, tangent is the same thing as when I say opposite over adjacent. Well, opposite over the adjacent, when you're dealing with, yeah. Yes, it is root 2 over 2. What am I doing here? Thank you. Let me just scribble that all the way out. I'd use my eraser, but I don't have one. Okay? Root 2 over 2. Thank you. You know, I'm not going to give away the tangent thing yet. That'll be for another lesson. Okay, any questions? All right, let's go ahead and turn the page. Exploration 2 says use the definitions of the trig functions to explain why each trig identity is true. Why does sine theta equal cosine of 90 minus theta? Talk about it there. Okay, let me take for a minute. If I know the sine of theta is equal to the cosine of 90 minus theta. Now, when I say theta here, remember I'm talking about an angle measure. So if I say, for instance, the sine of 30, let's plug in a value. So sine 30 is equal to cosine of 90 minus 30, right? We're just replacing our variable theta with that value of 30. Well, that's saying sine 30 is equal to cosine of 60. Is that true?
Yes.
Yeah. 1/2, 1/2. That's what we just talked about. Okay? They both equal the opposite over the hypotenuse. So if I say the sine of 30, well, when I'm looking from this angle, if I'm going from that angle, the sine of 30 is 1/2. Well, the cosine of 60 in relation to this angle is still 1/2. Okay? All right. Hey, guys, when you're looking at this, this happens to be a property that we'll deal with a little later. Same thing with this one. All right, why don't you take a look at letter C there. Okay, so sine theta equals 1 over cosecant. Is that true? Okay, sine theta is equal to opposite over hypotenuse. Everyone agree? Yeah. All right. Cosecant. Oops. Should really find my pencil. Do I have that here? Is that my other? Oh, no, I actually got one. Okay, cosecant is equal to? Good. It's the hypotenuse over the opposite. All right, 1 over cosecant. For those of you like, I don't get this, this just means the reciprocal. of, if I say 1 over cosecant, that would be the same as saying 1 over hypotenuse over opposite. Everyone with that? We just plug in hypotenuse over opposite for cosecant. Okay? So to prove that this is actually a true statement, this means 1 divided by hypotenuse over opposite. Everyone agree that's what it means? Okay? Which is the same thing as 1 times opposite over hypotenuse, which is opposite over hypotenuse, which is the same thing as sine theta.
Now I got it.
Okay? That's what that means. This, anytime you see 1 over something, that means the reciprocal of it. So this means the reciprocal of tangent. And we've already talked that cotangent is the reciprocal of tangent. All right. How many are with me so far? Guys, we're putting in a lot of different properties right now. Okay, let's go into letter E. Use the definition of the trig functions to complete each trig identity. Sine squared, or sine theta squared plus cos theta squared is equal to what? Talk about it with your groupies. Anyone have any idea what to do? Matt? So you're using like opposite and adjacent. How about using numbers? Yeah. 90 squared? Could we do this? Can we pick values for theta? Like, we have some values on this previous page, right? Like 30 is 1/2. So let's say theta is 30. So if we have the sine of 30 squared, what is sine 30? 1/2 squared. Well, no, it's not always 1/2, right? I mean, it could be 6. It could be any angle. We just have some values that we could try. Okay, so 1/2 squared plus, what's cosine of 30? Root 3 over 2 squared equals what? What's it equal? Equals 1. Well, we can't just make a general rule based on one angle measure, so what other angle measure do we have? We have 60 degrees. Well, what was it for 60? Root 3 over 2 squared plus 1/2 squared. I've seen this movie before. It's the exact same thing up here, right? You're just adding in a different order. Still equals 1. What other one do we have? 45. What is that? Dude, that's 2 root 2's over 2 squareds. Man. One half plus 1/2, which is 1. So, now we could keep doing this. However, it looks like sine theta squared plus cos theta squared is equal to 1. And that would be true. That'll make a lot more sense a bit later down the road, I promise. I'll actually show you pictorially why that works. Okay. All right. I want you to do the same thing here. Secant squared theta minus tan squared theta. What does that equal? Use some of your values that you know. Use your 30, your 60, your 90. What do you guys think? 1? Uh-oh. Let's check. Here's my work for it. So we get 30 degrees. That's 2 root 3 over, or 2 over root 3 squared minus root 3 over 3 squared is 4/3 minus 1/3, which is 1. Dude. Don't know why I didn't make that 1/3. I made it change it to 9, so that's kind of crazy. But okay, secant squared, or theta squared minus tan theta squared is equal to 1. That is called a Pythagorean identity. All right. I want you guys to take a look at those 2 questions on the bottom there. How can you find a trig function of an acute angle? Okay, summarize your learning there. And then number 4, use the calculator to find the lengths of x and y. Okay, can I get your attention back up here? Hey, how can you find the trig function of an acute angle, theta? Well, if it's a right triangle, you just use the ratios, right? You're using Sohcahtoa. Okay? That's what you're doing there. There's nothing magical about it. Okay? Number 4, though, use a calculator to find the lengths of x and y. This isn't magical either. However, if I want to know x and y, if I trace that angle, and I'm trying to find x happens to be my adjacent side, and that happens to be the hypotenuse. I know that adjacent and hypotenuse, if I'm using Sohcahtoa, adjacent and hypotenuse is which of the trig functions? Cosine. Cosine is equal to the adjacent over the hypotenuse. So the cosine of my angle is equal to the adjacent side, x, over the hypotenuse of 1. Which means cosine of 25 is the length of x. So, in your calculator right now, I want you to calculate what cosine of 25 is. Now, compare with your neighbor. Let's make sure we have the same answer there.
X equals about 0.91.
Now, what becomes a problem here?
It's really
Some of you are in which mode? Check your mode. You got to be in which mode? Degrees. We are measuring in degrees, not radians. So click mode and go to degree. Make sure it's highlighted. Now, I will tell you when geometry is using my graphing calculators or algebra, they're all in degrees right now. Okay? Eventually, you're going to move to radians, but when I do cosine of 25, 0.91 if we round. Okay? Put this leading 0 out there. I want everyone to find out what y is now. So what does y equal? 0.42. Okay, we have done a ton of stuff now. Just in that exploration, the last 20-ish minutes or so. I want you to tell your neighbor 2 things that you've learned. Okay, can I get your attention back up here? All right, any questions so far? And I know there's a lot of stuff. Kendall had a question, will we be able to use a note card on the test quizzes? I'm pretty sure we'll allow one, but I've got to talk it over with Mr. Vogel. Okay. On 9-1, page 244 of your student journal, please note there's a bunch of places for vocab, a good place to summarize your learning later. There's a lot of the core concepts that we've talked about today. Your different ratios there. A good place to take notes and summarize your learning tonight. Okay? And then you have your reciprocal functions down there. And remember, when you see 1 over something, that means the reciprocal of. That is new format for some of you. How many didn't know that before you came in today? Okay, that means the reciprocal of cosecant. Okay, whenever you see 1 over something, it's referencing the reciprocal of. Okay, and then on the next page, there's a trig values for special angles. Now, you'll note back in geometry and algebra, we talked about 30, 60, 90, and 45, 45, 90. The reason you spend so much time on special right triangles and knowing those relationships is because that is the foundation of your trig. You will use these triangles all chapter, all throughout trig. You will get sick of these angle measures. This page right here is a nice page to have. Okay? It tells you the sign, but you're going to eventually memorize all of these. Okay? So if we allow note card, I got to figure out a way to check your note card so we can't have the special angles on there. You will memorize these. You will fill out a unit circle with every single coordinate and radian measure on it. It'd be awesome, man. Yeah. All right. Now, just so you know, we have this here. Hey, pay attention, please. Remember, a 60-degree angle, a 30, 60, 90 triangle is just half of an equilateral triangle. So if you recall, this side is, if it has a length of x, this side has a length of 2x, and this side has a length of x root 3. And in a 45, 45, 90, if this was x, this is x, and this is x root 2. And that's how they're getting the root 2 there. They just plug in 1. Once you plug in a value for x, you can find all the other measures there. That is not new to you. That should be a review. Okay. I want you to take a look at page 246. Number 2 is where we're going to start. I want you to evaluate the 6 trig functions for the angle theta. In other words, write the ratios for that angle. Write the ratios for those 6 trig functions. All 6 of them. On number 2. Sorry, that's blurry. There we go. Okay, sine theta is equal to, that's our opposite, that's our adjacent, that's our hypotenuse. Sine is opposite over hypotenuse, or 4/8, which is 1/2. Cosine, well, that means you have to find the adjacent side. How are you going to do that? You do the Pythagorean Theorem unless you recognize that this is a 30, 60, 90, right? If this side, the shortest side, is half of the hypotenuse. That's x, 2x. This is x root 3, which is 4 root 3. You can get the same thing using the Pythagorean Theorem. It's just quicker if you recognize special right triangles. Okay? So that means you have adjacent over hypotenuse, or 4 root 3 over 8, which is root 3 over 2. Tangent is opposite over adjacent, 4 over 4 root 3. Those cancel. That's just root 3 over 3. Cosecant is the reciprocal of sine, so it's 2. Secant is the reciprocal of cosine, so it's 2 over root 3, which is 2 root 3 over 3. And cotangent is the reciprocal of tangent, which is just root 3, right? All right, now if you're struggling with any of that, we need to talk. Remember, tangent here, I just flipped it from this point. I could flip this one, but it's easier just to say that's 1 over root 3 here and just flip that one. Right. If you flip this one, it's going to be 3 over root 3, which is root 3 or 3 root 3 over root 3 squared, which is root 3. A lot of 3's there. All right. I want you guys to take a look at number 3. It says, let theta be an acute angle of the right triangle. Evaluate the other 5 trig functions. All right. Now what this is actually asking you to do is to take an angle of a triangle, call it theta. So theta is an acute angle of our triangle. And we know tangent is equal to 1, which means the side opposite of theta, over here, I'm going to use P for opposite, because O looks for it like a 0, and the side adjacent to theta, that divided by that is 1. All right? So let's pick some value. I could put anything in, right? You want to put 6? Okay. Can I just use like easy values like 1? 1 over 1? I know, that's so boring. What does that make this? 1 root 2 or root 2. I know, so boring. All right, you got to evaluate the other. In other words, write out the other trig function.
Which means theta's 45.
Okay? Your assignment tonight is going to be to finish this page. Finish 1, 4, 5, and 6. 1, 4, 5, and 6. Do your best.